Hello, hello, hello. We are back with Chapter 7, Collecting, Displaying, and Analyzing Data, focusing on Lesson 2, Box and Whisker Plots, and this is the guided practice. So we just finished doing some box and whisker plots, and now I want you to try to use the data to make a box and whisker plot here listed below. So I want you to go ahead and try that one on your own. So go ahead, press pause, work out number 1, and when you get done, press play, and we'll go over your results and see if you did it correctly. All right, see you in a bit. See you in a bit. Okay, we are back. We're going to make a box and whisker plot with this data set here. So the first thing we need to do is put the numbers in order from least to greatest. So I'm going to go ahead and do that now. My numbers are 12 and then 18, followed by 20, then 24, then 32, 35, and 36. I'm going to count them up to make sure every number is represented. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, perfect. So when I look at this, the first thing I need to determine is my least value. My least value is equal to 12. My greatest value is equal to 36. I'm going to go ahead and determine my median, which is the number in the middle. So to do that, I'm going to take one from this side, 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 and there we have it. There's my median. Perfect. So my median is 24. Then I need to determine the lower quartile. The lower quartile. Which is the median of these numbers right here. So that means I'm going to take one from this side, take one from this side, and there we have it. The lower quartile is 18. And then I need to determine the upper quartile. So the upper quartile is the median of these numbers here. So to do that, I'm going to take one from this side, take one from this side, and there it is. There's the upper quartile, 35. And now I'm ready to create my box and whisker plot. I know that my box contains the median, the lower, and the upper quartile. So I'm going to go ahead and make those marks first. So my median is 24. I'm going to make a large mark for that. Lower quartile is 18, so I'm going to make another large mark equal in size. And the upper quartile is 35. 35 would be right here. So another large mark there. Now I'm going to create my box, which represents 50%, the middle 50% of the data values. Okay, now I just need to put on my whiskers. So I have the least value at 12, just a little whisker there, and draw your line. And then the greatest value is 36. Oh, wow. That's a very, very little whisker. And yeah, those are, that's a box and whisker plot. So if you did that correctly and you have all your values correct, great job. Let's move on to the next problem. And we're going to do these ones together. So this problem states the box and whisker plot shows the test scores of 2 students. Use the box and whisker plot for exercises 2 through 4. So if you look here, we have 2 box and whisker plots stacked on top of each other. This represents test scores of Amy and test scores of Ed. So what we're going to do is we're going to analyze this information. This tells us a lot of information, right? This is Amy's least test score, which is 76. This is her greatest one, which looks like it's 89. The median test score looks like it's 81. And then I would say the middle 50% of her test scores are between 78 and 86. Whereas when we look at Ed, his least test score is 70. His greatest looks like it's 90. his median is 80, and the middle amount of his test scores are between 76 and 88. So there's a ton of information. We can really compare these two students by looking at these two box and whisker plots. So with all that said, let's go ahead and answer these questions. It states which student has the greater median score. So we know that we're dealing with the median. The median is this middle line right here. And when we look at it, it is obvious that Amy has the greatest median score. Okay? Number 3 says, which student has the greater interquartile range of test score? Now, this is a new term, the interquartile range. And what the interquartile range is, interquartile range. Now, I'm going to give you abbreviation for the interquartile range that we're going to use. It's IQR. That is what we're going to write for the interquartile range. The interquartile range is found by finding the really the distance between the upper quartile and the lower quartile. So you're finding the difference. You're finding out how spread out the middle 50% of the data is. So it's the upper quartile subtracted by the lower quartile. Okay? So that's how you find the interquartile range. Now we need to figure it out for each student, okay? So Ed's interquartile range would be his upper quartile value, which is 88, subtracted from his lower quartile value, which is 76. And I'm just going to figure that here, 88 minus 76. That would be 8 take away 6 is 2, 8 take away 7 is 1. So Ed's interquartile range equals 12. All right. Now I need to figure out what is Amy's interquartile range. Okay, let's go Amy. Okay, so Amy's interquartile range would be her upper quartile, which is, oh wait, let's talk about this. This means Ed's interquartile range, which means the middle 50% of the data is spread out by 12 units. So from 76 to 88, that is 12 units. That's what it means. Okay, back to Amy's interquartile range. Her upper quartile looks as if it's 86, subtracted from her lower quartile, which is 78. I'm just going to go ahead and subtract those really quick. 86 minus 78. 16 minus 8 is 8, and then that's a 7. 7 take away 7 is 0, so it's 8. So Amy's interquartile range is 8. That means the middle 50% of her test scores are only spread out by 8 units. Okay? So this question is asking us which student has the greater interquartile range of test scores, and Ed's interquartile range is greater than Amy's, so Ed's would be, his is greater. So Ed's interquartile range is greater than Amy's. Boom. All right, cool. Number 4 says, which student has the greater range of test scores? Okay, so remember to find the range, we just take the maximum value or the greatest value and subtract it by the smallest value. So let's go ahead and find Ed's. Ed's range is Ed's range. Ed's range is going to be his biggest value, which looks like it's 90, subtracted by his smallest value, which is 70, and 90 take away 70 is 20. So that means that Ed's range is equal to 20. And then we need to find Amy's range is equal to her max, which looks like as if it's 89, subtracted from 76, her least value, least value is 76. 9 take away 6 is 3, 8 take away 7 is 1. So Amy's range is equal to 13. So it says, which student has the greater range of test scores? That would be Ed. Ed again. Ed's range is greater than Amy's. Just a small little cloud running out of room. It's going to be a small petite cloud, accentuating our answer. All right, number 5 says, which student appears to have more predictable test scores? Explain your answer. Well, when I'm looking at Amy, Amy looks like her interquartile range is less than Ed's, which would mean that this middle 50% of her test scores, she scores more consistently in this range, whereas Ed's middle 50%, he is not as consistent in his scores. They are kind of spread out. And then if we look at the range, Amy's range is less than Ed's range. Ed's range is way further spread out, which means his test scores are kind of like all over the place, where Amy's test scores are more consistent within this range and interquartile range. So for those reasons, I would say that Amy has more predictable test scores because her interquartile range and range are both less than Ed's. So because her interquartile range and range are both less than Ed's, that means that her scores are closer together, which means if they're closer together, then they are more predictable. Ed's are all spread out, so his test scores could really be anything. So yeah, that would be the answer for 5. Okay, so now it is your turn, ladies and gentlemen, to go ahead and go on to this next problem here. So you're going to use this box and whisker plot. You have 2 of them. The box and whisker plot shows prices of hotel rooms in 2 beach towns. Use the box and whisker plot for exercises 6 through 8. So go ahead and finish 6, 7, and 8 on your own. So now it is time for our pause dragon. Remind you to pause your device. And when you get done with 6, 7, and 8, go ahead and press play, and we'll talk about the answers and see how you did. All right, see you in a bit. Okay, we're back. Let's go ahead and look at problem 6. It says, which town has the greater median room price? So we have Surfside here with the box and whisker plot, and we have Port Eagle here. So I'm going to look at the median for Surfside. That would be here. And the median for Port Eagle would be here. So which town has the greater median room price? Well, it would be this one, Port Eagle. Port Eagle has a median of $220, whereas Surfside has a median of, I don't know, something less than that. Would probably be somewhere close. This will be 190. I don't know, maybe 195, something. No, it wouldn't be that. 180, 220. Okay, that would be 200. So it might be something like 210 or something like that. Okay, so anyways, all this is asking is which town has the greatest median room price, which would be Port Eagle. Port Eagle. Perfect. It says which town has the greater interquartile range of room prices. All right, remember the interquartile range is found by taking the upper quartile and subtracting it from the lower quartile. Okay? So let's go ahead and do that for each town. So let's start here with Surfside. Surfside interquartile range. The upper value would be, okay, right down there. This is, okay, it's 220, 260, so halfway between that would be 240. So this is 240. So that's 240. Subtracted from the lower quartile range, which is 180. So I'm going to take that over here to the side. 240 minus 180. 0, take away 0 is 0. I'm going to have to borrow for that one. 14 take away 8 is 6, and then that's a 1, and then that's it. So Surfside interquartile range is 60. Now we need to figure out Port Eagle. So Port Eagle interquartile range is going to be the upper quartile, which is 300, subtracted from the lower quartile, which is halfway between 100 and 140, which would be 120. I'm going to go ahead and do that off to the side. 300 minus 120. 0 take away 0 is 0. I'm going to have to borrow from this 3, making that a 2, and that a 10. 10 take away 2 is 8, and then 2 take away 1 is 1. So, man, that's quite a big interquartile range. So, Port Eagle interquartile range is equal to 180. So what is this question asking again? Which town has the greater interquartile range of room prices? So it's pretty obvious that Port Eagle has the greater interquartile range of room prices. Okay? All right, so if you got that one right, great job. Let's see, I'm trying to get it in here, get in my little bubble or cloud. I could do better. Okay, problem 8. Which town appears to have more predictable room prices? Explain your answer. So when I'm looking at this, the middle 50% of Surfside is spread out by 60 units. Whereas the middle 50% of Port Eagle is spread out by 180. This means that I would say that Surfside would have more predictable room prices. Yeah, I'm going to go with that one. So Surfside has more predictable room prices. Oh, I didn't really have any space there. Because its interquartile range is less than Port Eagle's. So if you got that one right and you got all the other ones right, great job. You did a wonderful job, and we will see you next time. Bye-bye. See you later.